Evet, ses deneme, deneme, ses deneme, ses deneme. Okay. Uh, Hello, everyone, and welcome back. Last week, we talked about deep learning, one of the most important foundations of modern artificial intelligence. We explored how neural networks work in layers, how they learn from data, and how they can process complex information like images and sound. Today, we are moving on to a brand new, and really exciting topic, natural language processing, or NLP for short. This topic is special because it is where AI gets closest to human interaction. Machines today don't just see or calculate, they can understand, write, and even talk. So, today we will explore how computers process human language, how they translate text, detect emotions, summarize long articles, and even have conversations like this one. By the end of today's lecture, you will have a much better understanding of how systems like ChatGPT, Siri, and Google Translate actually work behind the scenes. Okay. Think about it. You talk to Siri, get a translation on Google, or chat with ChatGPT. You are using NLP in action. It is what helps computers read, write, speak, and even listen in a way that feels natural. So first, what exactly is natural language processing? The definition and purpose. NLP is the field of AI that tries to bridge the gap between human communication and computer understanding. Humans use language full of emotion, slang, and context, while computers only understand numbers and logic. NLP helps translate between the two worlds. For example, when you say, "Hey Siri, remind me to call mom at 8 p.m." Siri has to recognize your voice, understand the words, analyze the intent, and finally execute the task. That entire process, from listening to understanding, is powered by natural language processing NLP. The goal of NLP is simple to describe, but very hard to achieve: to make computers understand and generate human language, not just literally, but also in context. Let me give you a quick challenge to show why this is hard. If I say, "Can you open the window?" You know, it's a polite request, not a question about ability. But a computer might take it literally: "Yes, I can," without realizing you actually want it to perform an action. That's what makes NLP such a complex and exciting field. It is not just about words, but meaning. NLP process actually, how does it actually work? Now let's talk about how NLP works behind the scenes. When a computer processes language, it goes through several stages. You can think of it like how our brain works when reading a sentence. Step 1. Text processing. Text pre-processing. Before understanding language, we need to clean and prepare it. Imagine getting a massive paragraph with extra spaces, punctuation, and unnecessary words. The model needs to simplify it first. So we use techniques like tokenization, breaking a sentence into words or tokens. Example, I love AI. First, first token is I, second token is love, third token is AI. We split it out. And stop word removal. Removing words like the, is, on, at, of, they don't add much meaning. The third one is stemming lemmatization. It's reducing words to their root form, like running to run, or he runs like run, the simple form. After this stage, the text becomes structured, easier for the model to analyze. Step 2, syntax and semantic analysis, synthetic analysis. Once the text is clean, we need to understand grammar and meaning. Syntax analysis checks the structure, which word is the noun, the verb, the subject. Example, the cat sat on the mat, subject is cat, verb is sat. Semantic analysis goes deeper. What does the sentence actually mean? The cat sat on the mat could imply rest, ownership, or position, depending on context. NLP models use these two layers, syntax analysis and semantic analysis, these two layers to understand not just what is said, but what is meant. Step 3, language modeling. Finally, the magic happens. The model starts to learn patterns in language. In the old days, we used simple models like n-grams that predicted the next word based on a few previous ones. For example, if you say, I love, the model might predict you chocolate or music. I love chocolate, sensible, I love music, another sensible sentence. But now, thanks to deep learning, we have transformers, models like BERT or GPT that can process long-range context, understanding entire paragraphs, not just single words. That's how ChatGPT can understand your tone, style, and meaning across multiple sentences. Now let's look at real-world applications of NLP. Where do we actually use NLP today? Almost everywhere. You interact with technology that involves language. First one is machine translation. One of the earliest uses of NLP was in translation. Tools like Google Translate or DeepL, these systems used to make funny mistakes, right? They would translate word by word. But today, modern NLP models can understand idioms, slang, and context. For example, it's raining cats and dogs won't be translated as in Turkish language like hayvanlar yağıyor. No anymore. It understands it means heavy rain, yoğun yağış. The second one is chatbots and virtual assistants. NLP powers your smart assistants, Siri, Alexa, ChatGPT, and even customer service chatbots. They use NLP to understand your intent and respond naturally. Some advanced bots even detect emotion, whether you are angry, confused, or happy. and adjust tone accordingly. Third application step is sentiment analysis. This is one of the most widely used NLP applications in business. Companies use sentiment analysis to monitor what people say online about their products. For example, a brand might analyze 1 million tweets to see if people feel positive, neutral, or negative about them. Next one is automatic summarization. Imagine reading 50 pages of news or research. NLP can summarize it for you in a few sentences. It's like having an assistant that can read everything and give you the key points instantly. Text classification, another area, spam detection, topic labeling, fake news identification, all use NLP. Your Gmail inbox, for example, automatically classifies emails as primary, social, or promotions. That's text classification in action. Now let's look at current trends and developments. The field is moving incredibly fast. What was considered impossible 5 years ago is now everyday reality. Large language models, LLMs, the most powerful systems today, the GPT, BERT, Cloud, Gemini, are called large language models. They are trained on massive data sets of books, articles, and websites, learning not just grammar, but reasoning, style, and context. That's why they can write essays, generate code, or even hold long conversations. Another current trend is zero-shot and few-shot learning. Old models needed thousands of examples to learn a new task. Now LLMs can learn from just a few examples, or even none. That's few-shot or zero-shot learning. For instance, if you tell ChatGPT, translate this sentence into French, it can do it without ever being specifically trained for French translation. It has learned how to learn. I repeat it has learned how to learn. Multimodal NLP, we are entering another new era where language models don't just read text, but also see and hear. For example, ChatGPT with vision can analyze images, describe them, or even combine visual and text understanding. That's multimodal AI, integrating different forms of intelligence. Ethical and social challenges. Of course, with great power comes with great responsibility. NLP models can sometimes generate biased, false, or harmful content, not because they want to, but because they learn from human data. If the internet contains bias or misinformation, the models can reflect it. So, as AI developers, we have to think about ethics, fairness, privacy, and transparency. How do we make models that are powerful but also responsible? That's one of the biggest questions in AI today. These are the specific topics: hallucination and factual reliability. We talked today to make the AI clever, smarter, and also some privacy and copyright issues about law. The law differs from each country, from one country to another country. And so we need to care about copyright issues, and also data bias and misinformation is another big problem. Okay, let's keep going. Summary, bigger picture. Let's step back for a moment. Why does NLP matter so much? Because language is the essence of human intelligence. It is how we share knowledge, express emotion, and connect with each other. By teaching machines to understand language, we are not just improving technology. We are helping create systems that can support education, healthcare accessibility, and communication across the world. Imagine a doctor in Turkey communicating instantly with a patient in Japan using AI translation, or a visually impaired person using voice-based AI to navigate the internet. That's the true power of NLP, breaking barriers. About summary and reflections, let's recap what we have learned. NLP stands for Natural Language Processing, the science of teaching computers to understand human language. It involves text preprocessing, syntax and semantics, and language modeling using modern AI techniques. Real-world applications include translation, chatbot, sentiment analysis, summarization, and classification. Modern NLP is powered by large language models like GPT and BERT, and the future of NLP is moving toward multimodal understanding and ethical AI. If we summarize it in one line, machine learning teaches systems to learn from data. NLP teaches them to understand us. As you can see, NLP is not just a technical field. It's deeply human. It's about communication, empathy, and understanding. And as future engineers, scientists, or creators, we will likely interact with NLP. Whether you are building chatbots, analyzing data, or designing smarter systems. Next step, in NLP, we can explore how NLP connects with machine learning models and how you can actually build your own simple NLP system by using Python. Keep observing how language and technology interact in your daily life, every email suggestion, every voice assistant, every chatbot. Just focus. That's NLP quietly working in the background. Now let's pass to our new topic, data mining and big data. So far, we've explored how machines learn, how they process language, how they understand complex patterns. Now we are shifting our focus to something equally important, the fuel that powers all those AI systems, data. Without data, even the smartest AI model is like a car without gasoline. That's why today we are going to talk about data mining and big data, two pillars that allow us to discover knowledge and make intelligent decisions in the modern digital world. What is data mining? Let's start with the basic question, what is this? You can think of data mining as a modern form of digital gold mining. Just as miners search through tons of rock to find valuable gold nuggets, data scientists and engineers go through huge data sets to find useful patterns, insights, or trends. For example, when a supermarket analyzes thousands of transactions to discover that people who buy baby diapers also tend to buy wet wipes. That's data mining in action. So in simple terms, data mining is the process of discovering patterns, relationships, and useful information hidden inside large datasets. It combines statistics, machine learning, and visualization techniques to make sense of complex data. Now look at the data mining processes. How does data mining actually work? It actually happens in 4 key stages. Step 1 is data collection. We gather data from multiple sources, databases, websites, sensors, cameras, and even mobile apps. Think of how Google Maps collects location data from millions of users every second. Step 2, data cleaning, removing errors. Raw data is messy. It often includes missing values, duplicates, or incorrect entries. Before we can analyze it, we must clean it. This is a crucial step. Remember, garbage in, garbage out. If your data is poor, your AI will make poor decisions. Step 3, pattern discovery. Once we have clean data, we apply algorithms to uncover hidden relationships. For example, clustering, grouping similar data points like customers with similar habits, classification, predicting categories like spam versus not spam, and association rules, finding connections like market basket analysis. All we can count these words, these terms. And step 4 is evaluation and visualization. Finally, we interpret and present our findings in a meaningful way, often through graphs, dashboards, or reports. Visualization helps decision makers quickly understand patterns that would otherwise be invisible. Real life example, imagine you work for a bank. Before the concepts I will tell you about, real life example. Imagine if you work for a bank, you have millions of customer transactions every day. By applying data mining, you might discover people who make small daily purchases are less likely to default on loans. Customers who withdraw large amounts late at night are statistically more likely to be fraud cases. These insights help the bank reduce risk and improve service, all through data-driven understanding. What about big data? I will talk about big data. Now we hear this phrase all the time, big data is everywhere, but what does it really mean? Big data simply refers to data sets that are too large, too fast, and too complex for traditional tools to handle. Excel or a regular SQL database can't process billions of tweets, videos, or sensor readings coming in every second. That's big data. To understand big data better, experts often describe it with the 5V model. Each letter V represents a defining characteristics. First one is volume. The amount of data generated today is enormous. Every minute, people upload over 500 hours of video to YouTube, sent 16 million text messages, and make millions of Google searches. This volume is beyond human processing. Only machines can handle it. The second one, velocity. Data is generated in real time, not in months or years like before. For example, financial systems, sensors in cars, or stock markets produce new data every second. Big data systems process this information on the fly, often within milliseconds. Variety types. Data isn't just numbers anymore. We have text, images, videos, audio, GPS data, and sensor readings, all coming from different sources. Big data tools must handle this variety of structured and unstructured data. Fourth one is veracity, accuracy. Not all data is trustworthy. Fake reviews, incorrect measurements, and missing values can lead to wrong conclusions. Veracity means ensuring the data is clean, accurate, and reliable. And fifth one is value, meaning finally, the most important, V is value. Collecting massive data is useless unless it brings value like improving healthcare, reducing costs, or helping cities run more efficiently. Okay, now let's look at how big data differs from traditional databases. Traditional databases like the ones we use in SQL were designed for structured data, rows, columns, numbers, and well-defined schemas. But modern data is unstructured. Think of videos, tweets, or IoT sensor logs. That's why big data relies on distributed systems where data is stored across many computers. Instead of one powerful server, we use hundreds of smaller machines working together. Technologies like Hadoop, Spark, and data lakes helps us store and process this information efficiently. Meanwhile, cloud platforms like AWS, Google Cloud, and Azure make it scalable. You can grow storage as your data grows. Now let's check it out, real-world applications of data mining and big data. First one is finance and banking. Banks use big data for fraud detection, risk analysis, and personalized offers. AI models monitor millions of transactions per second to catch unusual activity, sometimes before humans even notice. And the second one is marketing and business. Companies like Amazon, Netflix, and Spotify are powered by big data. They analyze your behavior, then you watch, buy, or skip, and personalize your experience. That's why Netflix recommendation engine alone accounts for 80% of the shows people actually watch. And the third one is healthcare. Hospitals use big data to track patient history, predict disease outbreaks, and even assist in drug discovery. During the COVID-19 pandemic, data from millions of cases helped model the virus's spread and inform public policy. And next one is smart cities and IoT. Cities use sensor data to manage traffic, optimize energy use, and monitor pollution. For example, smart traffic lights can reduce congestion by adjusting signals in real time based on actual car flow. This is where big data meets AI to make cities more efficient and sustainable. The next one is social media and communication. Platforms like X, Twitter, Instagram, and TikTok analyze massive streams of user interactions to detect trends, filter harmful content, and recommend posts. Data mining is the reason your feed seems to know what you like, sometimes too well. And next section is learning from big data, tools and technologies. To handle all this information, we need specialized frameworks. Let's look at the main ones. Hadoop. Hadoop is one of the earliest big data systems. It stores large data sets by splitting them into chunks and distributing them across multiple servers. It is reliable. Even if one server fails, the others keep running. Apache Spark. Spark is the next generation. It is faster, smarter, and can process data in memory rather than on disk. That makes it ideal for real-time analytics. Companies use Spark for recommendation systems, fraud detection, and predictive maintenance. Also, Kafka and Flink, and these are streaming platforms that process continuous flows of data, like analyzing livestock prices or sensor data from autonomous cars. Instead of waiting for all data to be collected, they act instantly as events happen. Now let's look at the relationship between big data and AI. This is where things get really interesting. AI needs data to learn. The more data, the better the learning. Big data provides the fuel, and AI is the engine that turns it into insight. At the same time, AI also improves how we handle big data. It automates cleaning, detects anomalies, and even predicts future trends. For example, AI systems can detect fraudulent credit card transactions in real time using data streams. Or predictive maintenance models in factories use sensor data to prevent machine breakdowns. Or AI chatbots improve over time as they process more conversation data. This cycle, data feeds AI, AI enhances data, is what drives innovation in today's digital world. The human side, the human side of big data, let's not forget the human element. Behind every data set are real people. Their choices, behaviors, their privacy. As engineers and researchers, we have to handle data ethically. Questions like, who owns this data? How should it be stored and shared? What happens if it's used to discriminate or manipulate? These are serious issues we will keep discussing throughout the course, because responsible AI starts with responsible data. And final thoughts and summary about this section. let's wrap it up. Data mining is about discovering patterns and insights in large data sets. Big data is about handling massive, fast, and diverse information that traditional systems can't manage. Together, they make modern AI possible, fueling applications in finance, healthcare, marketing, smart cities, and more. Tools like Hadoop, Spark, and cloud computing make it all scalable and efficient. And as we move forward, AI and big data will become even more intertwined, shaping everything from self-driving cars to personalized medicine. So, in short, big data gives us the raw power, data mining gives us the intelligence. And next week, we will see how decision support systems and expert systems combine with these technologies to actually make choices, just like human experts. For today, thank you all for listening. Keep an eye on the world around you. Every application, every click, every transaction you make is part of the global big data network that's shaping our future. Thank you, everyone, and have a good weekend. And for 2 weeks, we will not have lessons because there are exams. There will be exams, midterm exams during these 2 weeks. And after the 1st December, in the second day of December, we will have next lesson, expert systems, but on 18 November and 25th November, there will be no any course. And 2 weeks later, on the second day of December, we will have next week. We will not have midterm exam. We will just have final exam. So in these 2 weeks, you will be free. You can study on different courses you take, but for fundamentals of artificial intelligence, there will be no midterm exam, just one exam on final time, no midterm exam. So you can just check these presentations and maybe you can do more searching about these topics on the internet, and maybe you will come prepared on the next course. So for today, that's all I wanted to say. Have a great exam term for the next 2 weeks, and see you in December.